Okay, hello finite math students. Today we will be working on Module 2.1, Graphing Absolute Value, Day 1. Content Standard, graph square root, cube root, and piecewise defined functions, including step functions and absolute value functions. Write equation of absolute value function. Language objective. Describe to a partner how to identify the vertex, slope, and direction of the opening of a variety of absolute value functions and obtain equation based on graph. Absolute value, written as double bar x, represents the distance between x and 0 on a number line. As a distance, absolute value is always positive. For every point on a number line, there is another point on the opposite side of 0 that is the same distance from 0. For example, both 5 and -5 are 5 units from 0. Thus, absolute value of -5 is 5, and absolute value of 5 is also 5. Okay, so then that's the number line. So the absolute value of x can be defined as a piecewise function, x for x greater than or equal to 0, or negative x for x is less than 0, where x is non-negative function. Simplify, return the number. When x is negative, the function returns the opposite of x. Complete the input-output table for x. So when x is -8, so absolute value of -8 is 8. So change that. Okay, and then for absolute value of -4, the answer is 4, 0. Absolute value of 4 is 4. Absolute value of 8 is 8. So now we can graph. Say plot the point we found in the coordinate grid. Use a point to complete the graph of the function. So we have -8 and 8. And -4 and 4, and 0, 0, 4 and 4, and 8 and 8. So then when you connect the line, we have that. So the absolute value is a V shape. Now examine your graph of f of x equal to absolute value of x and complete the following statements about the function. F of x is equal to absolute value of x is symmetric about the, well, if you look at it, symmetric means that you can draw a line through the center. The left and the right branches of the graph are the same, so then this go through the y-axis. And therefore the function is an even function. Okay, and the domain of f of x, so the domain is the x direction. So if you look at this x, there's a graph. If you look at this x, there's also a graph. So the domain is all real numbers. So we can write it as that, or you can write it as using this notation for all real numbers. The range is the y direction. Right? So if you pick this point, there's no graph for this point. But then our graph starts from here and then go on up. So then our range starting from 0, so we use the square bracket, meaning it's including the 0 from here, and we'll go on to positive infinity. Okay. Go on to number 3. So that you can apply general transformation to absolute value function by changing parameters in the equation. G of x equal to a times the absolute value of 1 over b times the quantity of x minus h, close parenthesis, plus k. So then we see that a, b, h, and k are called the parameter. But be careful that there's a negative here in the transform function. Right? So be careful of the h. Okay. So then say that for example a, we know that our a value is 4 and our b value is 1. So there's a 1 here that we don't write. And be careful with h. Remember we said that the negative is already in the function, so then h is 5. and k is a -2. Okay, so we see that the vertex or the parent function, so when we say that the parent function, we're looking for f of x equal to absolute value of x. So the parent function, the vertex is at 0, 0, and then for the transform function g of x, the vertex is 5, -2, or think of it as the value for h and k. So in this case, is 5 and -2. Right. Next, determine the location for each pair of points. So then here we want you to transform. Let me write it here. Right. So you want to transform 1, 1 over to 1 times b plus h, a times y plus k. Right, and you get, so then we have a point 1, 1 where we transform over 1 times 1 plus 5. A in this case is 4 times 1 what minus 2. So then the value is 6, 2. And -1, 1 will be transformed similarly. So we're -1 times 1 plus 5 and 4 times 1 minus 2. So then we get the point of -1 plus 5 is 4 and 2. Okay, so then that's why we have these 2 points here. So that's the vertex. That's one of our transform form points, and this is the other transform point. Right. Okay, so let's try part B. So from here, we know that our A is 1, and for B, so we have 1 over B equal to -1/2. So that means that B must be a -2. And H is equal to -3. And k equal to 1. So then that's our B, our H, and our K. Right? So first we're looking for the vertex. So let me call it V. So let's call it X and Y. So then your vertex is our H. In this case is a -3, and our K is 1. Right? So our point is -3 and 1. Okay, so now our transform, we're going to go from 1, 1 to 1b plus h, and for the y, ay plus k. Right, so we said 1 times a -2 minus 3, 1 times 1 plus 3, so we have a point of -5 and 4. And the other point we have -1 and 1. So we have -1 times -2 minus 3. 1 times 1 plus 3. So then we have -1 times -2 is +2 minus 3. So -1 and 4. So we have the other point -5 and 4 and -1 and 4. So then we graph the vertex -3, 1, so we have this point, and then -5, so and 4, so 1, 2, 3, 4, and then -1 and 4, 1, 2, 3, 4. So then we can connect the 2, right? Okay, and notice that these 2 points are symmetry. So then our line of symmetry will go through the vertex. Right? Okay, so then usually this point is called our line of symmetry. Okay, line of symmetry x equal to -3. Right? And then this point here, y, is the lowest point. Okay, so y equal to 1. Let's go on to the next one. So here, example 2, The equation is g of x equal to negative 1/5 absolute value of x plus 6, close to absolute value plus 4, find the vertex and two other points and use them to graph. So we're given that the vertex is negative 6 and 4. Well, before you do anything, let's look at our parameter first. Parameter a is negative 1/5. So since a is negative, so then we have a reflection in the x-axis. Okay, and our b is 1, h is negative 6, and k is a 4. Right, so we're given the vertex already, so we don't need to look for it. So we need to look for our transform point. So we say that this is 1b plus h and ay plus k. Right? So we say that this is 1 times 1 minus 6, negative 1/5 times 1 plus 4. So then we have negative 5, and this is 4, and oops, my mistake. Let me change that. We have 3 and 4/5. Right, so we have a point negative 5, 3 and 4/5. Another point we have negative 1, 1 transformed to negative 1 times 1 minus 6, negative 1/5 times 1 plus 4. So then this gives us a negative 7 and 3 and 4/5. Right, so then let's graph our vertex. It's negative 6, 4. So 1, 2, 3, 4, 5, negative 6. 1, 1, 2, 3, 4. So we have a point here. And then we have a point negative 5 and 3. Also, we have this point here, negative 7, this point here. So now our graph going to do this. Okay, notice that we see that there's a reflection across the x-axis, so our graph will be turning down. And we have our line of symmetry is that. And 4 is, in this case, then we have a reflection, this 4 here, will be the highest point. Okay, let's go on to our next one. Right, so we want you guys to try this. Okay, so since we're not in class, so I'm going to work it out with the rest of you guys. Right, so our perimeter here, A is just 1, B is also 1, and then there's H in this case is a 0, and K is 2. So then we know that the vertex is 0, 2. So let's try our transform. Right? So we said it's 1b plus h and ay plus k, right? Or xb in this. So we have 1 times 1 plus a 0, and 1 times 1 plus a 2. So we have a point of 1 and 3. And then we have negative 1 and 1. So negative 1 times b plus our h is a 0. And our a is 1, y is 1 plus 2. So we have a point of negative 1 and 3. So we can graph our vertex 0, 2 is here, and 1, 3, and negative 1, 3. So now our graph is going to do this. And then for number 2, if you look at our parameter, A is negative 2, B is 1, H is 4, and K is a 0. So the vertex is 4, 0. Right? So we said xb plus h, ay plus k. We start out at 1, 1, So we said 1 times 1 plus 4 and negative 2 times 1 plus a 0. So we have a 0.5 and negative 2 and negative 1, and 1 will go to negative 1 times 1 plus 4 and negative 2 times 1 plus 4. K is a 0. So we have negative 1 plus 4 gives us the 3, and this is still a negative 2. So our vertex is at 4, 0, and our 0.5, negative 2, 5, negative 2 is here, and 3, negative 2. So 3, negative 2 is here. So we have a graph. The reason it's going down is that this is a negative, so we have a reflection across the x-axis. Okay, let's go on to number 8. Okay, so same thing, so they say try it. I want to do this along with you guys. So we have A is a negative 3, so we know that we're going to have a reflection. Right? B is 1, H is 0, and K is a 5. So the vertex is at 0, 5. So X, B plus H, A, Y plus K. So we have 0.11. So we have 1 times 1, negative 3 times 1 plus 5. Oop, I forgot the H. So in this case it's 1, 2. Negative 1, 1 will go to negative 1 times 1 plus a 0. Negative 3 times 1 plus a 5. So we have negative 1 and 2. So the vertex is 0, 5 is here. And then 1, 2. So 1, 2 is here. And negative 1, 2 is also here. So the graph will open down. And this is our line of symmetry. Okay, number 4. So A is 1, B is also 1, H is a negative 1, so be careful with this. K is a negative 1, so then the vertex is negative 1 and negative 1. Right, so we have XB plus K and A, my mistake, XB plus H and AY plus K. So 1, 1 will go to 1 times 1 minus 1, and 1 times 1 minus 1 as well. So then we have 0, 0. And negative 1 and 1 will go to negative 1 times 1 minus 1, and 1 times 1 minus 1. So we have a negative 2 and 0. So the vertex is negative 1 is here, and then 0, 0 is here, and negative 2, 0 is here. So the graph will do this. Okay, and this is our line of symmetry. Okay, let's go on to the next slide. Said Charlie meets with customer on a daily basis. He uses the function f of x equal to 5 times the absolute value of x minus 8, close absolute value plus 20 to calculate how many dollars he charges per hour for his time. How much does Charlie charge per hour if a customer hires him for 3 hours? So that means that this is f of 3 equal to 5, absolute value of 3 minus 8 plus a 20. So this gives us 5 times absolute value of negative 5 plus a 20. This is 25 plus a 20, so the answer is 40. Okay, so then he charges $45. Number 6, find the lowest hourly charge Charlie charges. Show your work. Well, then this is absolute value. The graph is a V shape. This is, we see that is your lowest point, and it happens to be your vertex. So the vertex for this is 8 and 20, right? Okay, so then here's lowest hourly rate is equal to $20. Right? Okay, so this is the end of our March 2.1 day 2. Okay, so your assignments, and you also have your HRW. Okay, we need you to cover down 2.1 day 2 notes. All right, guys, so be safe.